take 10. All right, take 10.2. Relationships and patterns. We're going to try this again. Clusters and outliers. Wow. Associations, linear, nonlinear. Before we get into the actual notes, hopefully it works this time, we can show a little video from, you guys should remember this, Learn Zillion. Okay, they have a lot of neat deja vu, like we've seen this before. Learn Zillion. They have great stuff to look at online. Always go there if you need some math tutors or some help on anything. Let's see what we have.
So we're not increasing by the same amount each time.
All right, we'll start her.
Listen, we're helping students to distinguish between a scatter plot that is linear and one that has a curve in it, or linear versus nonlinear. The first thing we're going to do is just review. They've heard the word linear before, just kind of want to review to make sure they remember that linear means that it forms a line. A common mistake here, the students up until this point really haven't done a lot with nonlinear data, so they tend to think that everything is linear, and that is so not the case in the real world. So we're challenging the students to think outside of the line. Once we get into the core lesson, we're going to start with comparing the side length of a square and the perimeter of a square. This is a linear relationship because we know we basically multiply the length of the side times 4 to get the perimeter. So we multiply by the same number each time, thus giving us a linear relationship. Then I wanted to show them similar data, yet different. So this time we use the side length of a square and the area of a square. Both of these have positive trends, but we notice this is more of a curve rather than a line. And it makes sense because when we're calculating the area, we're squaring each side, or we're multiplying each side by itself, so we're not increasing by the same amount each time. This is a nonlinear graph, and we just want to point out to the students that in the real world, most relationships are nonlinear. Because the students have not seen as many nonlinear, I wanted to throw another example of a nonlinear graph in, where we're looking at the height of a ball over time, and it forms a curve, which is once again nonlinear. So, in simple terms, we just want to let the students know that if it forms a line, it's linear. If it forms a curve, it's nonlinear. As simple as that. And this is just helping the kids to move to the next level, just understanding the difference and being able to differentiate between linear and non-linear when interpreting scatter plots.
All right, now this second little video is also from Learn Zillion, and it's how to find clusters, if there's any clustering, and then find any outliers.
How do you figure out if doing more homework means getting a higher test grade? In this lesson, you will learn how to interpret a scatter plot by identifying clusters and outliers. Let's review scatter plots. A scatter plot is a pictorial representation of two pieces of data that have been collected from the same source. In this scatter plot, the x-axis represents the number of homework assignments completed out of 10 possible assignments, while the y-axis represents the test score earned by the same student. Once we draw the graph, we can look at the graph and draw conclusions about the relationship between the two pieces of data collected. In this case, we would use this to identify the relationship between completed homework and test scores. A common mistake when studying clusters and outliers is assuming that there will always be a cluster and or an outlier, but that is not always the case. In some cases, such as this graph, there is no cluster of points, therefore there is no outlier. Some scatter plots will have a cluster, but will not have an outlier because the points are in such a strong relationship. Let's look at this graph of homework completed versus the test score. As I look at it, I notice that these points form a tight cluster in an upward pattern.
Okay, I'm going to pause her for just 1 second. Now, this is how we'll do our homework, the clustering part. Now, I've been taught this 2 ways actually. I like it this way because it's easier to determine what your outlier is. But some classes, and when you get older, you might also, a cluster is like a tight knit. Is there a whole bunch of them that are really close together? Like, maybe in here. But I like this one because does this have an association? What kind of an association does this one have? This one has a linear or nonlinear association. Kind of a linear going in what direction? What did she just describe here? Upward, so that we know that as positive. Nice job. All right, and those are all questions that'll be on your worksheet.
When we think about points clustering on a scatter plot, these clusters can be in a form of a line or a curve. The tighter these clusters are, the stronger the relationship is between the two pieces of data that have been collected. Looking at this graph, the points are pretty close together, so I can conclude that there is a strong relationship between homework and test scores. You may have noticed that every time we looked at the graph and the clusters on the graph, there was always one point that was not included in the circle. This point is called an outlier because it lies outside of the cluster. Sometimes outliers occur because of an error in graphing the data, but sometimes outliers tell us something important about the data that we collected. This outlier shows us that a student completed all 10 of the assignments. However, they only made a 60 on their test. Let's think of some possible reasons for this.
Okay, what are some possible reasons that you think that outlier is where it is? Why did that student study that many, or did all their homework, but yet only got a 60% on their test? What are some possible reasons for that outlier? Not studying for the test, they did all their homework, okay?
Cheating.
Well, if they cheated, okay. Anything else?
They did their homework, but they did it all wrong.
They did their homework, but they did it all wrong. That's a good one. Didn't understand it. Anything else? All right, let's see what she says.
The student could have completed all 10 homework assignments, but not really understood what they were doing.
All right,
Therefore, never
got that one right.
mastered the material and still making a low test grade. Or the student could have experienced test anxiety. Although they knew the material, they may have frozen up and not been able to perform well on the test. Or the student could have just been inaccurate in their reporting when they told the person collecting the data how many homework assignments.
Or maybe they were sick that day, didn't
completed.
feel well. Maybe they were timed.
Because there was such a strong clustering of points, and because there was only one outlier, we can still draw the conclusion that doing more homework does mean getting a higher test grade most of the time. So it would still be in our best interest to complete our homework.
All right. Now, back to your notes. Let's fill those in. Relationships and patterns. So, the vocabulary, an association. Does it have an association? It could be, we talked about being linear association. It could have a curved association. Or if it's a scatter plot that looks like a yard sale, no association, we have no idea where stuff's at. That does not have an association. This one, these do. Or the negative one. Now, if it has an association, and if it's linear, if it's one of these two, we ask, well, then what correlation does it have? It can have either the positive correlation, going in that direction, or the negative correlation going in that direction. If it's no correlation at all, what would that be? Yes. You got that scatter plot. If it has all over, there's no correlation on that whatsoever. Yep, so here on your worksheet, and this is what your worksheet looks like also, in this diagram, in that picture, is there association, yes or no? Do you see an association? Or is it a yard sale? It's an association. Yes, we can see an association. What kind of an association do we see? Kind of a curved pattern there, right? So is it linear or nonlinear? It is non-linear. Then it says if linear, is the correlation positive or negative? Well, it's not linear, so it's neither. So we don't even have to worry about circling anything there. How about this one? Is there an association? Yeah. Yes. What is it? Looks like it's kind of going this way. We're going to learn trend lines tomorrow on how to put a nice straight trend line in that cluster. But anyway, so if this is, did you say linear or nonlinear for this one? Linear. Positive or negative? Negative. Good one. Negative. All right. How about here? Association, yes or no? Yes. Good. Linear or nonlinear? Linear. Good. Positive or negative? Positive. Excellent. Because it's running in this direction. How about here? Is there an association? Nope, got a yard sale going on. No correlation, nope, nothing. All right, now here's where you can draw your clusters and see if we have any outliers. I'll make this just a little bit bigger. When I look at this graph, do you guys see any clustering? Like I said, I've been taught two different ways where this looks like it could be a cluster. But see, if you go by that, that's kind of a clustering, then it's kind of hard to say, well, where are your outliers? Then everybody thinks all this is an outlier, when technically they're not outliers. So I like the way that the clustering is taught on this part of it. Do you see an association? Okay, so is it linear? And so we can circle this nice tight-knit group of data points right there. And it asks us, list any outliers. See, when you do your clustering like that with using the correlation, it's super easy then to see, is there an outlier? Yeah. Big time. What is the coordinates of that outlier? List any outliers. What are they? What is it, I should say? 50, you have to guesstimate. 50 what? 7? Yeah. And 57, or I'd have taken 58, but this one's exactly, we know that. What's that? 40. And 40. Is there correlation? Yep, we already answered that. What was the correlation then? Positive. There's a positive correlation. Okay, one more. Is there association here? Yep. Definitely. So is there correlation? Yes. What type of correlation? Let's circle up here. It says if there is clustering, circle the graph. Okay. Are there any outliers in this graph? None. So outliers, none. And what kind of association or correlation does this have, did we decide? Negative. That's all there is for today. Tomorrow we get to learn the trend lines.